Hello friends, welcome you all in my video lecture series on solution of partial differential equation. So these days we are talking about the Lagrange method. So earlier we have already discussed of type 1 and type 2 method. Today we are talking about type 3 Lagrange method to solve partial differential equation. This is Brajesh Kumar Jha, Faculty of Mathematics. So first we see how we approach in the Lagrange method. So the general PD that we can see here, it is in the form of capital P, small p, capital Q, small q is equals to R, where capital P is what? If Z is the function of x and y, so it is del Z upon del x, and Q, small q will be del Z upon del y. Capital PQ and R are what? It is a function of x, y, and z. So its solution can be defined in the form of phi u v is equals to 0, where u and v are two different solutions of the auxiliary equations. Let's say u x y z is equals to c1 and v x y z is equals to c2. So the auxiliary equations can be defined in this way. Dx upon capital P is equals to dy upon capital Q and dz upon capital R. So this we must remember before going for any kind of solution using Lagrange's method. So this up to this level you have studied for the type 1 and type 2 as well. So what we see in the difference from the type 1 2, in the type 1 you can select any two fraction and solve it and repeat two times, so u and v that you can get. In type 2, suppose you are taking any two fraction and solving, then that can be substituted in the second problem. So the substitution method can be applicable in type 2. Now in type 3, what we can see, we will talk about the Lagrange's multiplier. So Lagrange's multiplier is applicable, that we can write here LDX plus MDY plus NDZ upon LP plus MQ plus NR. If we write in such a way so that the denominator is equals to 0. If denominator is 0, then this numerator will give you what? One solution. Here L, M, N are said to be Lagrange's multiplier. So it is our part how we select LMN so that the denominator will be 0, that L into capital P multiplication, M into capital Q, N into capital R, so that we can put we can define this is equals to 0. So again two times you can do and you can have a two solution, or any type 1 method, type 1 you can use for the first solution, type 2 you can, type 3 you can use for the second solution. It depends on the problem. So let's take the example. Solve this question is given. You can see on the screen. Here the capital P is what? Up to this level. Capital Q C minus A upon B up to Zx into Zx, and this whole term, that is your R that we can define. So its auxiliary or a subsidiary equation can be written as what? Dx upon capital P, so A goes to in numerator, A upon B minus C yz, same way B upon C minus A zx dy, and C upon A minus B xy into dz that we can write. So our part is, if you can go through the any one method, type 1, that can be also applicable. If you can do, you can get the solution. Here our purpose to solve using the type 3. So by taking the Lagrange multiplier, if we take x, y, z, x, y, z means what? This is your L, this is your M, and this is your N. So by taking this, what we can see here, in numerator and denominator we are multiplying by L, M, N, So it is ax dx plus by dy plus cz dz that we can have, and in the denominator if you multiplying here by x, so it is xyz, here by y, so it is again xyz, and here it is also xyz. So xyz will be common, and rest part you have b minus c plus c minus a plus a minus b. So you can see here by equating these all, denominator will be 0. Now since we have shown here the denominator is 0, so the from the numerator that equals to 0 will give you the one solution, u or v. First solution usually we denote by u. So ax dx plus by dy plus cz dz will give you the solution. So now what we do by integrating this, what we get, it will be ax square by 2 plus by square by 2 plus cz square by 2. So c by 2 that you can consider, and by taking the LCM, the whole constant that you can write here, c1. So this is your first solution that we can see here. Now, so this is your what? This is u of x, y, z that you get here. Again, second time, what we consider ax plus ax. This is your L. M is equals to by, and n is equals to cz that we can get here. By multiplying, what we get here, it is a square x dx plus b square y dy plus c square z dz that we get here. And the denominator will remain same, that x y z is multiplied in all the terms, so x y z will be common, and now multiplying additionally we can multiply a here, so a into b minus c plus b into c minus a plus c into a minus b. Again, once we simplify it here, so denominator will be 0. So again denominator is 0, so numerator is equals to 0 can give you the one solution. Again, by integrating, what we get here, a square x square by 2 by ordinary integration that you understand here, x dx will be x square by 2, so it is a square x square by 2 plus b square y square by 2 plus c square z square by 2, and here c square by 2 that you can consider. So by taking LCM, it will be what? C2 only. So the required general solution will be what? It is phi uv is equals to 0, where u earlier that you obtained here, and this is considered as a v. So your answer will be this phi uv is equals to 0 is your required solution of the given question. Other than this, as I told earlier, you can apply any other method also. Suppose you are taking the first two factor only, so z will be eliminated and a, b, c are the constants, so directly you can get the solution. So this is also possible. So till it is not as apply the Lagrange method type 3, you can apply type 1. So number of solutions can be obtained. Now come to the next question. Here again, zx plus y, that is capital P, z into x minus y, that is capital Q, and this is your r, x square plus y square that we get here. So first step is what? To define the subsidiary or auxiliary equation. So always remember, it is what? Dx upon capital P is equals to dy upon capital Q is equals to dz upon capital R. So by defining this, what we get here, P that we can see z into x plus y, Q that is z into x minus y, and R is what? X square plus y square. So our part is what? To define the Lagrange's multiplier. Again, I said earlier, you can take any two fraction by type 1, you can solve, right? But here purposely we are trying to solve by Lagrange method type 3. So what we get? We take here L is equals to x, M is equals to minus y, and N is equals to minus z. So by multiplying this, what we get here, it is m dx minus y dy minus z dz. And in denominator, if you are multiplying with this one x, so xz into x plus y minus of yz into x minus y and minus of z into x square minus y. So always remember what we can see here. It has, if you are talking about the denominator should be 0. So almost 6 terms are there in the denominator. So 3 should be positive, 3 should be negative. But if you are adding denominator simply, so only 1 terms are negative. Rest 5 terms are positive. So that's why you require to maintain the plus and minus sign. So what we can see here, sign wise, according to sign, it is 3 plus 3 minus. Now the value should be the same. So it is xz, x square z plus xyz minus xyz plus it will be y square z. It is a minus of z x square. It is plus of y square z. So by having all the term, it will be 0. So here I can simplify it here. So it is what x square z plus xy z minus xy z. So minus xy z will be here plus y square z. So plus y square z that we can write, and minus of x square z will be there, and minus minus plus y square z will be there. Whole terms are 0. X square z minus x square z will be 0, xyz minus xyz will be 0, and here y square z plus y square minus y square z and plus y square z. This should be 0. Okay, this sign should be positive. According to the given question, this sign should be the positive. So it will be negative. So it is y square z minus y square z. A typo error is here. So it is y square z minus y square z will be 0. Okay, so what we see, denominator will be 0. So the numerator will give the one solution, x dx minus y dy minus z dz is equals to 0. Now simple integration can be performed here. So by integrating, what we get, x square minus y square minus z square is equals to c1. This is your first solution that we can define here. Now we take the we are going for the second solution. So L is y, m is x, and that can be considered as a minus z, as a multiplier. So again, once we multiply it, what we get here, so it will be yz into x plus y, xz into x minus y, and minus of uh, z into x square plus y square. So again, if we split it here, so first term will be x, y, z. Second term plus y square z. Third term is what? X square z. And this is minus of xyz. So it is minus of xyz can be written here. Again, minus of x square z, that I can write minus of x square z, and minus of y square z. So whole terms that can be defined as a 0. Again, we have successively we considered here the denominator is 0. We have proved here the denominator is 0. So again, the numerator is equal to 0 will give you the one solution. So y dx plus x dy minus z will be is equal to 0 will give you the one solution. Again, by integrating, what we get here. Okay, can we integrate here directly? No, because y dx cannot be integrable. But what we can see here, y dx plus x dy, that can be written as d of xy and minus of z dz. Now it can be integrable. So by integrating it, what we can get here xy minus z square by 2 is equals to c2, or 2xy minus z square is equals to c2, that we can write here. So by integrating, what we get here, 2xy minus z square is equals to c2. This we have performed earlier in the previous examples of type 1 and type 2. so that you can go through this one also. Now by having the third and fourth solution, this is considered as a v of x, y, z. So our final solution will be phi ub is equals to 0. This is the required solution of the given question. I hope so you understood these questions. Now we will move to the next question. Next question we have again here. It is a capital P, it is capital Q, it is capital R. So L, M, N are the constant here. It is not Lagrange's multiplier. So in the place of L, M, N, you can put A, B, C also. In some book it can be considered as A, B, C. So the subsidiary equations are given by, or subsidiary or auxiliary equation that we can write: dx upon mz minus ny, dy upon nx minus lz, and dz upon ly minus mx. So what we can see in this question, earlier the type 1 can be applicable, but here type 1 cannot be applicable. So directly we can move to the type 3. Type 2 is dependent on type 1. So what we do here, we consider the L is equals to x, M is equals to y, N is equals to z. So do not be confused with this element and the given question in element. In the given questions, element are the arbitrary constants, but here element is what? Lagrange's multiplier. So in the auxiliary equations, L, M, N cannot be changed. Only the x, y, z are the variables that can be changed. So once we are multiplying with the x, so what we get here, x into mz minus ny plus y into nx minus lz and z into ly minus mx. Again we can separate it here. So I can write here m xz minus n xy plus n xy. This term minus y into lz will be minus l yz and z into ly. Z into ly, so l yz, so plus l yz is there, and it will be minus of m xz. So that I have written earlier also, minus of m xz. So minus nxy plus nxy, it is 0. This is also 0, and this can be also this is also 0. So whole terms are equals to 0. So in this way, denominator equals to 0 we have proved here. So by the method of Lagrange's method of type 3, what we consider, this equals to 0, numerator is equals to 0 will also give the solution. So by integrating, what we get it here, x square by 2 plus y square by 2 plus z square by 2 is equals to c1 by 2, that you can consider. Actual integration is what? X square by 2, y square by 2, z square by 2, and constant that also we can take c1 by 2. So 2 can be eliminated. So your answer is x square plus y square plus z square is equals to c1. Now come to the next. Here the multiplier L, M, N we have taken in the same way. L is equals to M, M is equals to M, N is equals to N, because in the equation we have L, M, N. So now this is considered as the same because the value we have taken the same. So the fractions will be L dx plus M dy plus N dz, and multiple will be L mz minus Ny, y nx minus Lz, z Ly minus Mx. So once we again break it here, so it will be L mz minus L ny plus N xy just a minute, we have to make a mistake. It is not y, it should be m, it should be m. So m and x, so it will be m and x. Okay, it will be n m x minus m l z, so minus lmz can be written here, and ln y plus ln y. So it is plus ln y, and it is minus nmx. So it is minus nmx. So whole term equals to 0. So in this way we can put here, this is denominator equals to 0. So what we see, the numerator is equals to 0 will give you the solution. So by integrating L dx plus m dy plus n dz, we can integrate. So L, m, n are the constants. So integration of dx will be x, integration of dy will be y, and integration of dz will be z. So it is lx plus my plus nz is equals to c2. So this is your second solution, b of xy, that we can consider. B of xy z is equals to c2. So having the considering these two, this is your required solution. So I hope so you understood this Lagrange method type 3, but for the continuous understanding, we may go to the next question. So what we can see in the fourth question. This is your fourth question that is given here. So x into y square minus z square, that is the capital P, minus of y into z square plus x square, that is q, sign that should be considered, and this will be what? R. So in this way, the auxiliary or substitute equation that can be considered here, dx upon capital P, that is x into y square minus z square, and dy upon minus of y z square plus x square, and r, that is dz upon z into x square plus y square. So what we can see here, the one negative and two negative that is given here. Only the thing is how it is. See, xy square is here, and xy square that you cannot see. So some multiplier we required. Sign wise it is okay. So if you multiply the first, that is L is equals to x, so it is x square y square. Here also x square y square, that can be considered. So L, M, N. By considering this these multipliers, what we see here, x dx plus y dy plus z dz in the numerator, that we can see, and in denominator it is x, it will be what, x square y square minus z square, and it will be minus of y square into z square plus x square, and here it will be z square x square plus y square. Again, if you simplify it here, so it will be x square y square minus of x square z square minus of y square z square, and this will be minus of x square y square. So that can be written here, minus of x square y square. Next is x square z square. So plus of x square z square and plus y square z square. So whole denominator term is 0. So what we can see here, it is x dx plus y dy plus z dz is equals to 0, that we can see here. So now according to Lagrange's method type 3, the numerator will give you the answer, x dx plus y dy plus z dz is equals to 0 will give the solution. Hence by integrating what we get, so it was x dx plus y dy plus z dz is equals to 0. So for beginners, sometimes we integrate here. So it is x dx will be what, x square by 2, y dz, integration of y dz, it is y square by 2. Same way it is z square by 2 is equals to some constant. So constant that we consider as a c1 by 2. So by taking the LCM, 2 will be neglected here, deleted. So only x square plus y square z square is equals to c1 will be your first answer. It is u of x, y, z. Come to the next. If we eliminate this these x, y, z, so it is simply x square, y square, z square, right? So this y square, and here if you put minus, so minus y square will be cancelled. Minus of z square, and here if you put minus, so plus z square will be cancelled. By putting minus, it will be minus x square here plus x square. That can be considered here. Let's see what happens. L is equals to 1 by x, m is equals to minus 1 upon y, and n is equals to minus 1 upon z. So what we get it here, 1 by x dx minus 1 by dy dy minus 1 by z dz, and this will be, x will be eliminated, so x will be cancelled here, so it is y square minus z square. Next, minus minus plus, and y will be cancelled, so it is z square plus x square. And the last one, by having the minus 1 by z multiplying, you get here minus of x square plus x square plus y square. So this y square and y square will be cancelled, this x square will be cancelled, and this z square will be cancelled. So thus denominator is 0, so the numerator is equals to 0 will give you the one solution. 1 upon x dx minus 1 upon y dy minus 1 upon z dz. So you must know what is the integration of 1 by x. So by integrating, what we get it here, 1 by x integration, for beginners sometimes we write it is log x minus log y minus log z is equals to log of c2. So by the property of logarithms, it is x upon yz is equals to log of c2. So both sides we have the log function, so x upon yz is equals to c2, that we consider. So this is your v of x y z is equals to c2. So thus we obtain both the solution of subsidiary or auxiliary equations. So our the required solution of the given problem, 5 x square plus y square plus z square x upon yz. So earlier we had obtained x square by 2 plus y square by 2 plus z square by 2. So that can also be written, no issue. You can also write x square by 2 this 2 if you are considering the c1 itself, or c1 by 2. So these constant will not affect the solution. So I hope so all of you have understood the Lagrange method type 3. If you have any question, you can write in the comment box. So thank you for watching this video. I hope so you understood the Lagrange method type 3. So you can like, subscribe of my channel. If you wish, you can share with the other students. If you have any question, query, you can write in the comment box. These examples are very helpful to understand solution of partial differential equations. Once again, thank you for watching this video. These are some questions I am putting here for your solution. You can solve it. If you find any difficulty, definitely you can write in the comment box. Thank you.